All right, guys, Mr. Antonucci here, and in this video, we're going to talk about maximizing area. So our first example here, we have a rectangle inscribed in a semicircle of radius 2, and we want to find the dimensions of the rectangle that has the maximum area. So I'm going to show you two ways to do this one. The first, we're going to use some geometric methods, and then we'll use some trigonometric methods. So either way will work. So if you can see by the picture here that the area of the rectangle is equal to 2x times y, because the width of the rectangle is twice the x value and the height is the y value. So the equation of a semicircle is the top half of the circle of radius 2. So that would be x squared plus y squared equals 2 squared or 4. If we solve that for y, you subtract x squared, take the square root, and it'd be square root 4 minus x squared. Now we substitute that expression in for y in the area formula to express the area as a function of just x. So this would be 2x times square root 4 minus x squared. All right. Note that the domain of this function is between 0 and 2. Now, the next step we want to do is differentiate this. So the derivative, we have to use the product rule. So the derivative of the first is 2 times square root 4 minus x squared plus 2x times the derivative of the square root part, which is going to end up being negative x uh, over square root 4 minus x squared. Remember, if you have square root of a function, the derivative with respect to x is the derivative of the inside over twice the original square root. So I just call that the square root trick. Since the inside here is 4 minus x squared, the derivative of that would be negative 2x, but the 2 in the denominator here is going to cancel. So this is what we have. Now, if we clean this up a little bit, we could factor out a 2, and you'd have square root 4 minus x squared minus x squared over square root 4 minus x squared. Okay. Now we can simplify this even more. If we multiply the fraction by root 4 minus x squared over itself, or excuse me, if we multiply the square root part, the radical right here, okay, you would end up with 2 times 4 minus x squared minus x squared over root 4 minus x squared. And then we can simplify that and get 2 times 4 minus 2x squared over the square root of 4 minus x squared. And then we could factor out a 2 and a negative from the numerator, and this would give us negative 4 times x squared minus 2 over square root 4 minus x squared. Now, the only critical number in the open interval 0 to 2 is going to be square root of 2. That's the only number that's going to make the numerator 0. If you have x squared minus 2, that's going to be 0 when x is plus or minus root 2, but you can't have negatives here because the domain, again, is from 0 to 2. So x equals 0, or excuse me, x equals root 2 is the only critical number. That makes 8 prime of root 2 equal to 0. All right. So the value of the area function, we can evaluate it at the endpoint and at root 2. Okay, if we plug in 0 to the area equation, when x is 0, If I plug 0 in here, that's going to make the whole function equal to 0. And if I plug in 2, um, you would have 2 times the square root of 4 minus 2 squared. So you'd have a 0 under the radical, which would make this equal to 0. When you plug in root 2, you get 4. So the max area is 4. All right. And so the length is 2x, which is 2 root 2, and the height is equal to the y value, which would be um, square root 2 in this case. Okay. All right. So let's look at the other way to do this using trig. Okay. So we have the same picture here essentially, but we're going to draw a radius of 2 across that triangle or rectangle there and put theta, the angle theta, in standard position, as you can see in the picture there. Then x equals 2 cosine theta and y equals 2 sine theta, where theta is going to be between 0 and pi over 2. Okay, because the theta has to be in that first quadrant. All right, then the area of the rectangle is equal to 2xy, which is 2 times 2 cosine theta times 2 sine theta, which is going to be 8 cosine theta sine theta, which by the double angle formula is equal to 4 sine 2 theta. Okay. Since the area is a differentiable function of theta, we can take the derivative and find the critical number. So A prime is going to be 4 cosine 2 theta times 2, which is 8 cosine 2 theta. This equals 0 when cosine of 2 theta equals 0. So that means that 2 theta has to equal pi over 2, because cosine of pi over 2 is 0. And that means that theta itself would have to be pi over 4. So the only critical number in that interval is pi over 4. Now we can evaluate the area function at 0, pi over 4, and um, pi over 2. Again, when you plug in 0, now we're plugging in 0 into the area function here for theta, not for x or y. So sine of 0 ends up being 0. Sine of pi over 2, well, it's 2 pi over 2, which is pi. Sine of pi is also 0. And then when you plug in pi over 4, you get 4 sine of 2 times pi over 4, which is pi over 2. Sine of pi over 2 is 1, so you get 4. And again, the area is maximized when the area is 4. And so again, the length is going to end up being 2 root 2, and the height is going to be root 2 here.